Alright, welcome to the problem number 9 breakdown video. If the other explanation was a little confusing or you want to see it in more detail, we're going to cover that here right now. So let's start by picking a color that I don't generally use. Yep, pumpkin looks good. Alright, so we know the general surface area formula is 2 times the height times the depth plus 2 times the height times the width plus 2 times the depth times the width. So the big difference here is we can't just plug it into the formula, and I believe there is an answer that will give you the number of gallons if you were to make the mistake to use this formula as it's given to you on the test. And we're going to talk about why this formula isn't going to work on this problem. So here's our swimming pool. It's been pulled up out of the ground, and we've color coded it. Now what I'm hoping to show you with the color coding is why this formula does not work, and where it's going to fail us is at this point. So I've color coded. So surface area is basically summing the area of every surface of a three-dimensional object. So here we have the opposite sides here. We've color coded in red, so we do have 2 of those, and to find their area we need the height times the depth of this three-dimensional figure. And if you look over here, you'll see that I've basically removed these 2. So we're breaking the pole down into its components. And what we have here is our height times our depth. And we have 2 red boxes. Well, here we have our height times our width, which would be this one and this one. And if you want to look at it, that would be this front plate, which was kind of hard to represent a difference in. So we have a front, the side facing us, and then we have the rear panel, the side up if we were standing here looking at the pool. This would be the front panel and this would be the rear panel, excuse me. So we color code those in a light blue, and we do have 2 of those also, which would be represented in the light blue here. So we have our height times our width, and then we have 2 of those panels. So I went ahead and broke them down to the component of the pool right here for us. Now this is where the formula will break down in its generalized form. We only have the depth times the width once, and this purple represented by this purple coloring. We only have 1 of these. And that's because this top one where I've drawn water, cresting, is because you have to be able to enter the pool and you have to be able to exit the pool. And if you go swimming down in here, you're going to want to be able to come up for oxygen. So we're not going to paint the top surface. So we only needed 1 purple section. So I've taken out the bottom. And now if you can kind of imagine assembling this, putting these, here, and then the red ones here, we would have a fully enclosed area that would hold water for us. So what's going to be different about the formula here is we're only going to take the area of, where did my pen go? 1, 2, 3, 4, 5 sides, not 6, because like I said, we need to be able to surface for air or enter and exit the pool at this point. So the formula we're actually going to use is 2 times the height times the depth plus 2 times the width times the height plus 1 time the width and depth. So this is also W down here. And then we don't need 2 times here because we need to be able to come up for air. So that's pretty much it. If there's any further questions about how surface area works for this problem or what's going on, please let me know in the comment section. I would love to make another video to make this as clear as possible for you.